Hi everyone. Welcome to the USACO January Gold Level Live Solutions session. So I'm Max. I guess about myself, I'm an instructor at XCamp. Some credentials: I was an ICPC World Finalist and a Code Forces Grandmaster, and I'm currently in charge of teaching the 602 level class at XCamp. And I'll be presenting us a solution today. Yeah, so these are the three problems we'll be looking at today. It's from this just most recent contest. So walking in Manhattan, Calvitancy, and nap stores. So I actually want to go ahead and share my whiteboard now so I can first talk through how to solve each problem step by step, and then we can look at the knowledge required for these afterwards. So let me go ahead and switch to sharing my whiteboard. Okay, hope everyone can see that. Yeah, so let's begin with the first problem. So the first problem was a competency. So this is problem one, and the setup goes as follows. So we have a bunch of cows and we have a bunch of roads. So these roads are going to be they exist in a 2D plane. So they're either going to be like horizontal lines, they run infinitely horizontally, or they run infinitely vertically. So there'll be some lines like this. And there are a total of I believe there are a total of n less than 2 times 10 to the 5 lines.
Okay, can you hear me now? Hello? Okay, there we go. Oh my goodness, okay. Now if it crashes again, if it crashed my laptop, then it was just not meant to be. But yeah, I'm on my laptop now. So all right, 210 to the 5 roads, 210 to the 5 queries. We want to, and what does a query look like? A query looks like we have a cow that starts at some location, and the cow is going to be moving. It's going to move until it hits, like, say, a intersection at so the way it works is that when it hits an intersection, it will turn. It would continue moving either north or east depending on if it hits it at an odd time. So if it hits it at an odd time, then it will start moving. Then it will continue moving to the right. And if it hits at an even time, it will continue moving. It will continue moving up. So yeah. Okay, and so now the question is basically a bunch of queries of the form X, Y, and D, which tells you that some cow starts at position X, Y, and there was a move for D seconds. You know, they're gonna keep moving. At some point, they might hit this intersection at an even time, so start switching, moving to the at odd times. They start switching over to moving to the right, and then they kind of just follow this path. We want to know where do they end up after D seconds. Okay, so that is the statement. It is a bit of an overwhelming premise when you first look at this because you think I think the usual techniques for analyzing these problems don't quite work. If you try to think about it as a graph, you quickly realize there are up to n squared possible nodes because every intersection of like two different roads could be considered a vertex in this graph. So just even like thinking of it in this way is already too inefficient. So so kind of like a hint already to how we can possibly solve this is that we have to consider these as two independent parts, as like the x direction and the y direction. If we have to like couple these two parts together, there's absolutely no way we could hope to solve this in time. And so the key observation for this problem which is quite interesting, is that it actually is like the movement in the x and y direction actually are kind of independent. And so they're not exactly independent, but they kind of are. And let me explain what I mean by that. So let's say we're a cow, we're moving to the right, and let's say that at these particular times, so at these particular intersections, we will switch from moving to the right to moving up instead, because we hit each of these at an odd time. Or I always forget, I forget if it's odd or even for moving up. We hit these at an even time. Yeah. So we hit each of these time point positions at an even time. Um, and then if we hit each of these at an even time, then what happens is we will hit these at an even time. We will then move like perhaps we will move like up some amount of time. But notice that the next time we switch from moving up to moving to the right will exactly be at an odd time. Right? Because that is exactly when we are starting. That is exactly when we switch from moving up to moving right. So it's always that whenever it is an odd time at an intersection, we are moving to the right, and when it is an even time, we are moving up. Irregardless of like whatever we are doing, however much we move in this direction. What I mean, so like it's like when we hit this intersection at an even time, we'll switch to moving up. After some amount of time, we'll switch back to moving to the right. But it is guaranteed that it's the same cadence. We will again hit this intersection at an even time and then start moving up. It is never possible that like we move like some amounts going up and we end up in a situation where we're moving to the right and we hit this at an odd time. That is not possible because we always switch the directions on the exact same parity. And so when we say that means that like it's always going to be the same like positions or the same sets of positions of time where the same sets of like positions or the same sets of intersections where we switch from moving to the right to moving up. And the same argument can be made for moving up versus moving right. I could draw a similar diagram to show that the positions where we switch from moving up to moving right are always going to be the same positions, which is exactly when the positions when the time becomes odd. I received a request to quickly recap the statement again. I guess the statement in short is that we have a bunch of roads that are either infinite horizontal or infinite vertical lines. And now we want to answer like few queries where like, some cow starts at some position and it moves along these roads, and when it hits the intersection, it will move to the right. If it hits it at an even time, and it will, or sorry, if it hits it at an odd time, and it will move up when it hits it at an even time. So those are and then we want to know like answer Q queries of like if a cow starts at some position and moves for D seconds, where do they end up? Yeah, so this is a pretty key observation because this tells us that like it's always going to be the same cadences, the same like sets of positions where the same intersection like points where we switch from moving to the right to moving up. And so what does that mean? Now with that in mind, let's consider this. So our path is going to be that we move to the right, they move up, they move right, move up, move right, move up, right? We're gonna repeat that a few times. And so let's binary search on how many times we move right / up. So like this is like 1 step, 2 steps, 3 steps. Let's binary search on the number of steps. So let's binary search on the number of steps. And when we binary search the number of steps, let's just decide, let's figure out okay, so what is that? Once we fix the number of steps, because of this analysis, we immediately know like where we're going to be at which point we're going to be moving up. So we're going to move up like here, we're going to move up here, and we're going to move up here, right? And so we can first accumulate all the distance that we move in the x direction. And then because we move up, and because we know we move up here, here, and here, we can also independently calculate like how much we will move up in the y direction. So in the y direction is going to be a similar diagram where C might be moving up, and there are the cow will be moving up, and there are up to 3 positions or 3 rows where they switch from moving up to moving right. And we will also accumulate the total distance of this. And then we would just take the sum of the amount we move in the x plus the sum of the amount we move in the y and check if it is less than or equal to d. And if it is, then this many steps is valid, and we're trying to find the larger steps. We're trying to find the maximum number of steps we could take while we still take the total distance we move is less than or equal to d. And if we are able to do this computation, then we just find the maximum number of steps, and then we might have to also take an additional like move some amount to the right or to the up, which we can just simulate at the end or just manually check at the end. Do we need and I think someone in the chat asked if we need a prefix sums for this. I think it's even simpler than that. I think you just check like you can have a list of all the coordinates of where the intersections are, and we just binary search in that list. So we binary search for where the cow initially is, and then if we move 3 steps, it's just this x coordinate minus where the cow currently is. Yeah, and so to recap the total solution then is actually ends up being ends up being like a fairly short. It's just that for each query, we answer each query independently. We just binary search on the number of steps we take, and we independently figure out how much we move in the x direction if we take that many steps, and how much we move in the y direction if we take that many steps. Because we know that regardless of the x or the y, it's always going to be the same like positions that we hit for that many steps. And so we can just calculate that, check if something is a D, binary search for the maximum number of steps for it, which that is true, and then do the extra like casework at the beginning and end for like, because at the very beginning you might not start an intersection, so you have to first like simulate up to the first intersection, and at the end you might still move like a little bit extra on the tail end. So you just need to do that extra casework at the beginning and end. And this will give us we have O of n pre-computation, just reading in the input. Actually, it might be n log n because we have to sort it. And then so say n log n because you have to sort the x and y arrays. And then for each query, it's going to be answer log n, so it's q log n. So the total complexity is n plus q log n. And that's going to be fast enough to solve the full constraints for this problem. All right, so any questions on the first problem of the contest? Cool, so I'm going to present the second one now. Let's present the second problem.